Hello, welcome to yet another episode where we shall be looking at the proposed memorandum of the Mathematics Paper 1 for Grade 12's June examination 2025. So if this is your first time on this channel, please subscribe, feel free to comment and follow, press my like button, and I hope you'll enjoy yourself. Okay, so when we look at this paper, it was a 3-hour paper with 150 marks. Okay, the paper had 9 questions. The rest of the instructions are just as normal. Okay, so let's dive into this paper and see what we were meant to do with this paper. Okay, so with question 1, okay, which is the algebra. So we have 1.1.1 where they want us to solve for x, and we have a quadratic. So step number 1, we have to just take out what is common. Okay, factorize this. So I'll say x into x plus 4, okay, is equal to 0, meaning that my first x will be a 0, or my second x must be a negative 4. Then 1.1.2, they're telling us to solve this correct to decimal places. So the trick is that whenever we see correct to decimal places, that has to be the quadratic formula. Now with the quadratic formula, step number 1, we need to create a standard equation. So move the 3x to that side so that we have 2x squared minus 3x minus a half should be a 0, meaning that our a is a 2, our b is a negative 3, and then our c is negative a half. All right, so when I punch that into my calculator, remember the formula is a negative b plus minus square root of b squared minus 4ac over 2a. So substituting is going to be negative with a negative 3 plus minus square root. That's going to be negative 3 squared minus 4. The a is a 2. The c is negative a half. Everything is over 2 multiplied by 2. All right. So what do we end up with? So we're saying 3x, okay, minus a half. We're having that. So the first x value that I'm getting is a negative 0.15, or the other x value will be 1.65. So show us the quadratic formula, show us how you're doing your substitutions. You get all your full marks. All right, then 1.1.3, which is the quadratic inequality. So we still have to move to that side, create a standard equation. So this is going to be, okay, so we have 3x squared plus 5x minus 2. Okay, so he's saying 3x squared. Come on. 3x squared, okay, plus 5x minus 2 is greater or equal to 0. Let's factor this out. That's going to be 3x. It's going to be x. Let's have, what are you going to have here? A 2 and a 3. Let me have a 1 there, and let me have a 2 here. So that I have this as a positive 6 and a negative, okay? It's greater or equal to 0. So my critical values, x will be a 1 over 3, or x is going to be a negative 2. Now I have to represent this. So if I'm to use a parabola, our a is already a positive, okay? So if this is negative 2 and then this is a third, is that correct? Yes, a third. And then meaning that we're focusing on the area when it is greater than 0. So this is the shaded part that we are interested in, and this is the shaded part we are interested in. Alternatively, if we can say that x should be less or equal to negative 2, or x must be greater or equal to 1 over 3. So those are the solutions for that 1.1.3. Then 1.1.4, the question is an exponential, okay? We have 2 to the 2x, okay, plus 2 to the x minus 6 is equal to 0. Wow. Minus 6 is equal to 0. Okay, step number 1. Whenever we see a quadratic, I can just say, let my 2 to the x be any letter. Okay, I prefer letter k. Okay, so this becomes k squared plus a k minus 6 is equal to 0. Someone asks, how is this a k squared? Remember, we're having something like a 2x and then squared. That's how we come up with a k squared. So factor this out. We're going to have a k. We're going to have a k. This is going to be minus 2 and plus 3. So either k is a 2 or k is a negative 3. But remember, the question is not asking for k. It's rather asking for the value of x. So I have to go back and substitute k with 2x. So 2 to the x is equal to 2. Okay, same basis. X is 1. Or we can have 2 to the x is equal to negative 3. So we don't have exponents that give us a negative answer. So this one is out. Cancel it out. Or you can tell us that there is no solution in that format. So x is 1 becomes the only alternative for 1.1.4. Then 1.1.5, we have more or less the same thing here. So I can group that. I'm saying that's the same as this denominator. Ne? So I'll say that 1.1.5. So x squared, okay, minus 2x. And then we are adding a 3. And then plus 2 over x squared minus 2x should be equivalent to a negative 2. Is that correct? No. Equivalent to a 0. This is a 0. Let's not create our own questions now. Okay, so I'm saying let m be x squared minus 2x. Where there is x squared minus 2x, I'm going to represent it as m. Meaning that in this case, I'm going to have m plus 3 plus 2 over m is equal to 0. Okay, so step number 1, I'm just going to multiply through by m. Everything should be affected by m. So that's going to be m squared plus 3m plus 2 must give us a 0. Let's factor this out. So when you factor this out, we're going to have m plus 2 and then m plus 1 is equal to 0. So either m is a negative 2 or m is a negative 1. But remember, we say that our m is x squared minus 2x. Let's go back and represent that. Some people prefer calling it the k method. Well and good. So x squared minus 2x. We can bring this 2 over. So plus 2 is a 0. Okay. Alternatively, am I doing the right thing there? Alternatively, we can have x squared minus, was it a 2x or a 3x? Was it a 2x or a 3x? It was a 2x. Okay, so what are we doing there? Minus 2x. What am I, why am I having this kind of thing? Okay, minus this, we say plus 1 should be a 0. Okay, so what I'm going to start with, I can start from this, okay? When I look at this, there's no way I cannot have any factors that I can multiply or numbers I multiply to give me 2, but I plus them, I get a negative. That is absolutely ridiculous. Alternatively, if I look at my negative b minus 4ac, the answer I get is negative. So we don't have any roots. So we're going to say we don't have no solutions there. Then in this case, we can have x minus 1. And then x minus 1 is 0. So in this case, we have equal roots, meaning that x must be just a 1. All right, so that is how I would have approached 1.1.5. Then 1.1.6, the root, so isolate the root sign, meaning that we're going to have square root of x plus 5 is equal to x minus 1, or negative 1 plus x. Then step number 2, we need to square both sides. This is 1.1.6. Okay, let's use this one. Okay, so we're saying root of x plus 5 is equal to x minus 1. That was the first step. Second step, we need to square both sides. Okay, square that, meaning that we have x plus 5. This side we shall have x squared minus a 2x plus a 1. Let's create a standard equation. Let's move everything to one side. So it's x squared minus 3x minus 4 is a 0. You factor this out. This is x, and x can have a minus 4 plus 1. Okay, so either our x is a 4 or alternatively our x is a negative 1. Now we need to go back and test these answers of ours. Ne? So x plus 5, we said minus x should give us a negative 1. That was the original question. So if we use 4, okay, 4 plus 5 is a 9. Square root of 9 is a 3. Now 3 minus 4 gives us a negative 1, which is the same as that. Okay, so that is correct. This answer stands. Let's try with the negative 1. Negative 1 plus 5 is a 4. Square root of 4 is a 2. Minus, okay, minus 1, which gives us a 3. On the right-hand side, we have just a negative 1. So this, we cancel it out, or you can tell us that it is not a solution. So our answer is just a 4 for 1.1.6. All right, question 1.2. In this case, they brought a proper simultaneous equation, not those fancy stories of theirs. Okay, so step number 1, if I baptize this to be equation 1, baptize this to be equation number 2, I can get equation 1 and create a third equation and say that my x is going to be 5 minus 2y. Let this be my equation 3. Then I need to substitute equation 3 into equation number 2. So where I see x, I'll have 5 minus 2y. Okay, so my second equation, this side, I'll jot it this side and say that I have my 2y squared minus, this is xy, okay, and then we say minus 4x squared is equal to 8. That was the first, no, it's rather the second equation, okay? Let's substitute and see. So 2y squared minus y into, we say that our x should be a 5 minus 2y, okay? 5 minus 2y minus 4 into 5 minus 2y squared. I can push the 8 that side and I have a 0 there. So the entire expression is now having y's, okay? Let me open up the brackets. So 2y squared minus 5y plus another 2y squared minus 4. When I open this, I'm going to have a 25 minus 5 and 2 is 10 times 2, which is minus 20y plus a 4y squared minus 8 should give me a 0. Okay, let me open up with a negative 4, meaning that 2y squared minus 5y plus another 2y squared minus 4 times 25 is 100. That's going to be a plus 20y minus the 16y squared minus 8 should give me a 0. Let's now collect the like terms. 2, 4 minus that. So we have a negative 12y squared. Then minus 5 plus 20. What is minus 5 plus, why is it a 20? Like, isn't that witchcraft? Supposed to be 80. Hello, because 4 times 20 is 80. So negative 5 plus 80 is giving me a positive 75y. Okay, and then minus 100 minus 8, I'll get negative 108 is equal to 0. All right, so I'm going to divide through by negative 3. Okay, so I have my 4y squared minus a 25y plus by 3, I'm going to have a 36 is equal to 0. Let's factor this out. So this is a 4y and probably that's a y. For me to get a 36, I can use 4 and 9. Okay, I can have a 9, I can have a 4 minus minus. Let's see. That's a 16. That's a 9, which is a 25. Okay, perfect. So y is going to be a 9 over 4, or basically our y is going to be a 4. But remember, our x is 5 minus 2y. So let's substitute that and see what our x values would be. So if we are dealing with 9 over 4, it's going to be 5 minus 9 over 2, which means we're dealing with a half. So x is a half there. And then if we are dealing with 4, what is 5 minus 8, which is a negative 3. So OX will be a negative 3. So negative 3 and 4, a half and 9 over 4. So that is how I would have obtained those 6 marks. Then 1.3. For which values of k will the roots of this be real and equal? So number 1, for roots to be real, the inequality must be greater. For roots to be equal, they have to be equal to 0. So b squared minus 4ac must be greater or equal to 0. So let me write it this side and say 1.3. Okay, 1.3, we have 6x squared plus 6, okay, minus 4kx, minus 4kx. So rearrange this and we see what we get. So it's 6x squared minus 4kx plus 6. So the a is a 6, the b is a negative 4k, the c is also a 6. Now let's substitute into our determinant and see what we obtain. All right, so that's going to be b squared minus 4ac is greater or equal to 0. Our b, we said, is a 4k, so negative 4k squared. Minus 4, the a is a 6. And then the c is also 6. Ne? This must be greater or equal to 0. Okay, so 4k squared gives us 16k squared. What is 36 times 4? Okay, 36 and 4, that is a 2, 12, 14. So minus 144 is greater or equal to 0. Then I can use the difference of two squares, meaning that I have 4k minus 12, and then 4k plus 12 should be greater or equal to 0. So the first one, for the critical values, I'll have k being a 12 over 4, which is a 3. The other one, my k is going to be a negative 3. I mean, you could even divide through by 16, literally, okay, to simplify that. So for me to have this, my solutions will be k must be less or equal to negative 3, or k must be greater or equal to a positive 3. So those are the solutions, the values of k for which the roots will be real and then equal. All right, so those are the sweet 30 marks. All right, then question number 2. We're being told that the first 3 terms of arithmetic are these. Can we write down the next 2? Wow. So what is happening here? So T2 minus T1, they told us it is arithmetic, so we must have a common difference. So that is a 7. This is a 7. When we plus a 7, we must get a 16. Eh? You plus a 7, you get a 23. So those are the next 2 terms that the question simply wanted. Then can we show that the sum of the first n terms will be given as this? Now there is 2 ways to this. Okay, there are 2 ways to this. What we can do, we can say Sn is basically n over 2 into 2a plus n minus 1 into d. That's the formula for the sum of an arithmetic. Then let's do the substitution. N over 2, our first term is a negative 5 plus 7 is our d, meaning that we're going to have 7n minus 7. Okay, so negative 10 and negative 7, we get a negative 17, meaning that our n over 2 into 7n minus 17 is equal to the Sn. So this is what the question basically wanted. So probably they just want to see the substitution, how you're opening the brackets, and how you're basically collecting your like terms. All right, so that is 2.1.2. Then 2.2, they're telling us the first 4 terms of a quadratic pattern are this. They want us to get the value of x. So let me jot them this side and see. This is 2.2. So the first term is x, okay. Then 3x minus 5, all right. And then the next one is 4x minus 3. Beautiful. And then lastly, we have a 5x plus 1. Okay, so one thing we know about the quadratic pattern is that we have 2 differences. The first difference and then the second difference. So the second difference needs to be the same across. So let's get the first difference. So 3x minus 5 minus x, I'm going to have just 2x minus 5. Then for me to get this second term, we have 4x minus 3x, which is x, minus 3 minus minus 5 is giving me a plus 2. Okay, and then here 5x minus 4x is x, 1 minus minus 3 is giving me a plus 4. All right, then let me get the second differences. X minus 2x is just a negative x. Okay, 2 minus minus 5 is a plus 7. And then for this case, x cancels x. 4 minus 2 is a 2. The question is asking for the value of x. So we know that the second differences must be the same. So negative x plus 7 should give me a 2. Okay, let me move this to that side. Negative x becomes a negative 5, meaning that our x is a 5. Okay, so that is what I'm getting with my calculations. All right, so if x is a 5, we need to move on and ask ourselves, what is the next aspect? Then we're saying 2.2.2, if the pattern continues indefinitely, can we prove that all the terms of the pattern are positive? No, for us to prove this, the question is indirectly asking us to determine the Tn, because with the Tn, or the general term, that's when we can really define that the pattern is positive or negative or so. All right, so what are we going to do? Since we know that our 2a, the second difference is 2. So I'll say that our 2a is 2, meaning that our a is a 1. Then 3a plus b should be equated to this whole thing, okay? Now, if x is a 5, that's going to be 2 times 5 is 10, 10 minus that, so which means that is a 5, okay? Then let's replace a with 1, meaning that b is going to be a 2. Then a plus b plus c should give us the first term, which was a 5, because x is a 5, okay? So this is a 1 plus 2 plus c should give us a 5, meaning that c is going to be 2. So with that, we know that our Tn is just going to be n squared plus 2n plus a 2. Now, if this is the general term that we are getting, okay, what does this tell us? They are telling us that for any natural numbers, because they told us that for all terms, okay, for all the terms. So when n is 1, everything is positive. When n is 2, everything is going to be positive. So after getting a general term, you can just draw your conclusion. The fact that we don't have any negative numbers, okay, the fact that there are no negative numbers, we can say that all the terms of the pattern will be positive. So all the terms of the pattern would be positive. So this question was asking for the general term in a technical way. All right, then question number 2.3. Consider the geometric, okay? I like it when they tell us exactly what we are working with, okay? So I have p minus 3, 3 quarters p minus 3 squared, 9 over 8, p minus 3 cubed, and so on and so on. P is not a 3. Determine the values of p for which the series converges. Okay, so for convergence to take place, one thing we need to remember is that -1 is less r is less +1. What we need the common ratio. For us to get the common ratio, it will be a T2 over a T1. So when I do my magic to find T2 over T1, which means like it will be a 3 over 4, p minus 3 squared over a half into p minus 3. So p minus 1 bracket goes, and then I'm going to be left with just a 3 over 2, okay, into p minus 3. So I'm going to leave it as my r. Okay, so let me substitute that into my condition. This is 2.3.1. Okay, -1 is less 3 over 2, p minus 3 is less 1. So let's divide through by 3 over 2, meaning that we're going to have a -2 over 3 is less p minus 3 is less 2 over 3. Okay, alternatively, multiply through by 2, then divide through by 3. You still get the same thing. The -2 over 3 plus 3 is less p is less 2 over 3 plus 3. If that's a 9 minus 2, so I have 7 over 3 is less p is less 9 plus 2, 11 over 3. That is what I'm getting with my conditions, okay, with my solutions or values. Then 2.3.2, the last part of the 20 marks. If the sum to infinity is 1, can we determine the value of p? Now, one thing we need to remember is the formula, okay? This is 2.3.2. Know that sum to infinity is given as a over 1 minus r. Our sum to infinity is a 1. What is our a, the first term? So I have, okay, of p minus 3. Then 1 minus, what is our common ratio? We say 3 over 2 into p minus 3. 3 over 2 into p minus 3. Okay. What do we need to do next? Since this is a denominator, this is a 1, I can multiply both sides by this denominator. Okay, meaning that this entire thing is going to be multiplied by this, because it's the same as 1 over 1, and then you cross multiply. So 1 minus 3 over 2 into p minus 3 should give us 1 over 2 into p minus 3. We can open this up now freely. So 1 minus 3 over 2p this and that, we're going to get a 9 over 2 is equal to a half of p minus 3 over 2. All right, so let me collect the like terms. Okay, so when I collect the like terms, I can move this one that side. So negative 3 over 2p minus a half of p should give us negative 3 over 2 plus, it's supposed to be a minus. Okay, so minus 9 over 2 minus 1. All right, so on my left, I'm going to have a negative 2p. Okay, and then on my right-hand side, this is going to be a negative 12 over 2, which is a negative 6 minus 1, which is a negative 7. Divide both sides by negative 2, meaning that our p is a 7 over 2. This is what I'm getting. Guys, please advise me whether I'm doing the wrong thing or the right thing. So that's what I get for 2.3.2. And if I assume that all my answers are correct, then I already have 50 marks now. Yes. Then 3.1. If the sigma notation of k is equals to up to n, given as this is equal to that, can we determine the value of n? So in this case, they are testing about the summation, okay, the sum. So we can do the substitution, okay? Let's start by substituting. If k is 2, this is going to be 2 minus 1, which is a 1, 3, which is 6. Our first term is a 6. If k is 3, okay, that's going to be 9 times 2, which is 18. And then if k is 4, that's going to be 27 times 2, which is 54. So you can see that this is a geometric, whereby our a is 3, and then our common ratio, no, a is a 6. And then our common ratio is a 3. So let's deal with the sum, okay? We know that sum of a geometric is given as a into rn minus 1 over r minus 1. So where there is Sn, I'll replace the 59046 and then do the magic, okay? So 59046 is equal to my first term, which is a 6, into the common ratio, which is a 3 to the n, minus 1 over 3 minus 1. So when I subtract 3 minus 1 is a 2, 6 divided by 2, I'm going to get a 3. Then I'm going to have 59046 is equal to 3 into 3 to the n minus 1. Let me divide both sides by 3 to make life easy for me. Okay. When I do that, how I do that, I'm going to get 19. No, that's a lie. We cannot lie to small kids. So let's see. So it's saying 59046 divided by 3. No, we're not lying actually. We're telling the truth. 19682 is equivalent to 3 to the n minus 1. Move the 1 to that side. It means it's going to be 19683 is equal to 3 to the n. Now, if we factorize this thing, okay, so 19683, factorization, I'm getting 3 to the 9 is equal to 3 to the n, meaning that our n must be 9. So we're dealing with just 9 terms, or n is a 9. So that's how we would have obtained the 5 marks. I know there are some people that are very good at summarizing this, ne? Thank you very much. But then the answer should remain more or less the same. Okay, then 3.2. There is an equilateral triangle. So equilateral simply means the sides are equal. Ne? So we have a 12p units is drawn. A second triangle is drawn by joining the midpoints. Okay, but still the triangle remains equilateral. So we continue joining the midpoints and up until forever. Ne? Now, if this was a 12 initially, a half of 12p is going to be 6p. That's also 6p, meaning that that's a 6p. This is also a 6p. And then you divide it again, you're going to have a 3p, blah, 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 blah. So write down in terms of p the length of each side for the second triangle. So we're going to say it's just a 6p. Then 3.2.2, calculate in terms of p the perpendicular height of RST. So the height that makes 90 degrees with the base. Okay, so I'll divide this into 2. If that's a 19, meaning that I have a 6p, this is also a 6p. But initially, this was a 12p. Now they want me to find that. So I have to use my theorem of Pythagoras. All right, so what does the theorem of Pythagoras tell us? That if we have ta squared, we must be equal to, I don't know, I'll call it m, tm squared plus ms squared, but it's 2 marks. I don't know why I'm stressing with this. Meaning that my tm is going to be the square root, okay, of ms, which is like 6p squared, plus this one, which is like 12p, everything is squared. So that's going to be a 36p squared. Why am I saying 3? Malume, what's going on? So 36p squared plus a 144p squared under the square root sign. So 36 plus 144. What we get? We get 180. No? And then the square root of 180 is giving me, give me the third form, please, 6 root 5. So 6 with a p, but and the root of 5. So this is what we get, and that's what the question wanted for the height. You don't have really to go into the details of how you get this, how you get that, and no, it's not a big deal. Okay, but there's something. Someone's going to say, but why plusing? Yes, that is wrong actually. We cannot plus because we're looking for the height, meaning that we're going to subtract. Yes, Malume. What's going on? You can't be doing so. Can't be doing this. So he's saying Tm is going to be the square root of Ta squared minus Ms squared, meaning that it's a 12p squared minus a 6p squared altogether, okay? So 144 minus 36 is giving me 108, okay, but p squared. So when I simplify this, I'm going to get something like 6p, but with a square root of 3. All right, so that is what we would have obtained. 6 root 3 with a p. Okay, then 3.2.3. Can we show that the sum of the areas of triangles formed will not exceed this much? So the question is asking for sum to infinity, because this thing is decreasing infinitely. So we need to get the areas. So area number 1 is going to be a half times the base, which is 12p, now times the height, which is 6p square root of 3. So this cancels that, meaning that we have 36p squared with the root of 3. This is T1, or area number 1. When we look at the second area, okay, remember we said the height is being divided by 2, meaning that the new height for the second triangle is going to be 3p root 3. So meaning it's going to be a half, this is area 2, times the base, which is now 6p, then multiplied by the height, which is 3p root of 3. This cancels that, we're going to have 9p squared, the root of 3. So if I divide, let's say a2 over a1, because I want to get the common ratio, it's going to be 9p squared root 3 over 36p squared root 3, meaning that my common ratio is 1 over 4. All right, so let's go to the sum to infinity. Sum to infinity, this is 3.2.3. We know that sum to infinity is a over 1 minus r, okay? Our first term, or our first area is 36p squared root 3. Okay, 36p squared root 3 over 1 minus, we said our common ratio is a quarter. So when you simplify this, we have 36p squared root 3 over 3 over 4. So that is a 12 times 4, which is a 48 p squared root 3. Isn't that what the question really wanted? Yeah, but framed in a different way. But that is what the question was asking for. So that is the total, or the sum that we need. So the area cannot exceed that, because that's the maximum sum that we can obtain. All right, then question number 4, which is the functions. F of x, okay, we're given this general, and then the g of x, basic that, then a, b are x-intercepts, d is p, turning point. All right, then 4.1, they want the coordinates of f. So we know that f is the y-intercept of f. Okay, so this number is 15 over 2, but they want the coordinates, ne? So it's going to be 0 and then 15 over 2. We don't need a calculation for that. Or if you feel like, substitute x with a 0. Then you'll have your answer. Then determine the coordinates of C. So C represents the x-intercepts. Y is going to be a 0, and the graph that is passing through C is the G. So G of x, I'll put a 0 there, meaning that x squared plus 2x should be a 0, x plus 2, and then that meaning that x is a 0 or our x is a negative 2. They want the coordinates of C. So C is going to be negative 2 with a 0. Okay. Then 4.3, they want us to get the turning points of F and G lie in the same vertical line. This one. Determine the value of P, X value. So we know that if they have the same X value, meaning the axis of symmetry of G will be the same as that. So for me to get the axis of symmetry using G is going to be negative B over 2A, means that it's a negative 2 over 2 times 1, which becomes a negative 1. So we know that P is a negative 1. That's what they wanted. And then they want the length DE. So if this is a negative 1, okay, for us to get the length, we need the y coordinate here. Okay, we need the y coordinate. So I'll say G of negative 1 is going to be negative 1 squared plus 2 into negative 1. 1 minus 2, which becomes a negative 1. So our point E, okay, point E is negative 1 and negative 1. Point D is negative 1 and 8. So the length DE should be 8 minus 1, which gives us 9 what? 9 units. So 4.3.2, we have 9 units there. All right, then 4.4, can we show that A is negative 1/2 and then B is negative 1? So in this case, what are we going to do? So what I suppose, since I have the coordinates now of the turning point, I can use the turning point approach to work out this equation. Okay, so the best I could do, let me just change this for the best name. So it's saying y should be a into x plus p squared plus q. So a into x, that's going to be a plus 1 squared. Our q is, we said 15 over, no, that's the y-intercept, don't lie, do not lie. So that is 8 is equal to y. Then we can use x to be 0, and then we have 15 over 2. Okay, 15 over 2 is equal to a, if that's a 0, that's a 1 squared plus 8. Let's move this 8 to that side. So 15 over 2 minus 8. What we get? Oh Lord, we said over 2, not over 8. Okay, I'm getting negative 1/2. Okay, negative 1/2 is equal to a. There we go, automatically comes out. Okay, so if that is true, we need to get the value of b. We need to show that b is what? Is a 1. So I'm going to substitute this into the original and have negative 1/2 into, let me open this. I have x squared plus 2x plus 1 and then plus 8. Open this up further, it's negative 1/2 of x. That and that is negative 1. This is a negative 1/2 plus 8. 16 minus 1, which is 15. Meaning that we're going to have negative 1/2 of x minus, this is 1x. Okay, minus x plus 15 over 2. So we can see that the b is automatically a negative 1. So that is how we would have approached that question. Then 4.5, determine the equation of a straight line that is joining the points of intersection. You must round off your answers to 2 decimal places. Now, if we look at this, technically, this might be having the same y value technically. Okay, I'm just saying by the looks, né? But let's see. The x values are different, but we said we have a hint. If we get a fraction of 2 decimal places, do not be afraid, né? So let's see. The original f, okay, we said f of x is basically negative a half of x squared minus x plus the 15 over 2, né? And then our g of x is basically x squared plus the 2x. Then I'm just going to solve these to simultaneously equate them to each other. Okay, 15 over 2 must give us x squared plus 2x. Let's move this to that side. So 1 plus a half, we get a 3 over 2 x squared. This moving that side, we have a 3x. That one goes that side, we have a 15 over 2 is equal to 0. Then let's multiply through by. Will it work when we multiply through by 2 over 3? Because I don't want the fractions. So 2 over 3, 2 over 3, 2 over 3. And even this side, 2 over 3. So this cancels out. We have x squared. This becomes a 2x. And then this cancels. We have a minus 5 is equal to 0. All right. So you can divide it whichever way you want, guys. Né? But we must get the same kind of solution. So it's going to be x. But it's not going to make sense. I cannot have factors for that. That's a lie. Because I don't have any numbers I multiply to give me negative 5. When I plus them, I get a positive. So I could use the quadratic formula and say that negative b plus minus square root of b squared minus 4ac over 2a. Do the substitution. Negative 2. It's going to be 2 squared minus 4 times 1 multiplied by negative 5 over 2 times 1. So the first x that I'm getting to 2 decimals is negative 3,45. The other x is 1,45. Now, if I try to substitute these numbers back into the original, okay, either the g or the f, I'm getting a y as a 5,00. Okay, this one is also y is equal to 5,00. Now, if, okay, we're seeing that they have the same y value, which is a 5. Same y value. So the line that is passing here must be parallel to the x-axis. So the question is asking for the equation of the straight line that is joining the points of intersection. So meaning that y is going to be 5. Yeah, because the gradient is going to be 0. So that is what the question wanted. Okay. So that is what we have. Y-intercept is 5. The gradient is a 0. Change in y will be 0. Okay, question number 5, which is the exponential and the log. They're telling us the graph of f of x is given as this sketched below. Q is 1 over f and 2 is a point on the graph of f. P is a point of intersection. Okay, what do they want? They want the value of a. So for us to get the value of a, let's just substitute. Where there is y, we can put a 2. Where there is x, we can put a quarter. So it's a 2 is equal to the log of what? A with a 4. But this a is a base, okay? Meaning that even when we are flipping around from log form into exponential form, this a still remains. So a squared is equal to 1 over 4. Okay, the question is, what do we do? How can we express which as what and stuff like that? So if I have a squared, this can also be a half, but squared. Hello, okay, meaning that our a is a half. Alternatively, people can use the log to say log. No, not log necessarily. We can use what we call the square root, find square roots. Okay, meaning that a can be a plus or minus over half. Okay, a is a positive or a negative over half. That is according to the log format. Okay, then I'm taking a to be positive, but it could be otherwise. No? It could be otherwise, but I'll take it to be positive. Then can we determine the inverse? And we must write our answer in the form of that. Now, if in any case our y is the log. We're saying a half of x. Remember, for us to write the opposite of this, just gonna switch it around and say that y is gonna be a half to the exponent of x. And there we go. Then 5.2, they want us to sketch this inverse, and we must show at least 1 point. Now, initially, if y is a 0, okay, we're saying if y is a 0, what would be the x? Meaning that if we have a half, no, this is a y, no? We're saying it's a 0. So a to the 0 must give us the x value. So meaning that anything to the exponent of 0 will be just the 1. So this is a 1 and 0. So let's just switch these points. So if this is 1 and 0, then the other one is going to be 0 and 1, somewhere there. If this point is a quarter and 2, meaning that the other point of interest could be 2 and a quarter. This is a 2, a quarter could be somewhere there. And then just join, and then you draw your inverse. So we have something like that. So it should be cutting the y-axis at 1, and then it should be moving towards the x-axis. Okay, so that is our f negative 1 of x. Okay, then determine the values of x for which f of x should be greater than negative 32. Now, for f to be greater than negative 32, I need to solve for x, okay? Remember, we're looking at f. I'm going to use the inverse, okay? The inverse is telling me negative 5, né? So meaning that my y is going to be a half to the exponent of negative 5, meaning that my y is going to be a 32. So we're focusing on a 32 that is there. So if it's a negative 5, this must be a 32. 5 and negative 32, or negative 5 and 32, meaning that here is going to be a 32 somewhere. Okay, if that's a 32, negative 5 is going to be down here. Is that true? Because this is y. Yes. Now they're asking us, for which values of x will the graph be greater? So meaning above the negative 5. So at 32, the graph is at negative 5. For it to be greater, we're seeing that when it is less than. So between 0 and then the 32. So for me to answer that question, I'll say 0 is less x less 32. All right, so that is how I would have answered that question, okay? Question number 6. Question number 6. They're telling us that the sketch below shows the graph of f of x, which is the hyperbola, the g of x, which is a negative x plus k. We have those coordinates, they meet at those points, and so on and so forth. They want us to get the value of k. What is k? K is the y-intercept of the axis of symmetry. Okay, so for us to get this k, we have to use this intersection, or we have to use point D. So with D, I'm going to say negative 1 is equal to negative with a negative 4 plus k. So negative 1 minus 4 is a k, meaning that the k is a negative 5. Okay, I stand to be corrected, guys. No? So that is 4.1. Oh, it's not 4, it's a 6. Hello. Why are you still dreaming of 4? 6.1.2, they want the values of A, P, and Q. So from our hyperbola, we know that our P is going to be a 4. Okay, P is going to be a 4, we know that. So it's going to be A over x plus 4, and then minus 1 should give us the y or f of x. Then let's substitute a point negative 8 and 0. Okay, we're saying at A, which is negative 8 and 0. So 0 is going to be A over negative 8 plus 4 minus 1. Let's move this one that side. It's going to be a positive 1. Okay, is equal to a over negative 4, meaning that our a is negative 4. Then since the question is asking for a, p, and q, so a is negative 4, p we say it's a 4, and then q is negative 1. All right, then determine the values of x for which f is greater than g. 5 marks. Yo, way. Okay, where do we find f to be greater? So let's substitute and say that negative 4 over x plus 4 minus 1 is greater or equal to negative x minus 5. So like the deal breaker is, let's move the one that side. So negative 4 over x plus 4 is greater or equal to negative x minus 4. So let's multiply it through by x plus 4 and then x plus 4. Okay, so that cancels that. Negative 4 is greater or equal to, this is going to be negative x squared. This is going to be negative 4x minus 16. Let's simplify that, which is a negative 8x. Let's move everything to that one side, okay? So we have positive x squared plus 8x. When this one neutralizes that, we get a positive 12 is equal to 0. Everything positive, né? It's greater or equal to 0. Let's factor out x and 6. We have x and 2. Meaning that our critical values, x will be a negative 6 or x is going to be a negative 2. Okay. Now, if these are the critical values, how do we represent that? So this is going to be a negative 2. This is going to be a negative 6. Now, for which values of x is the graph of f? Okay, f of x is greater or equal to g of x. So at this point, f can only be greater to the right-hand side. So x needs to be greater or equal to negative 2. Okay, did the question have an equal sign? Perfect. Okay, then on the left, we're seeing that this f can only be greater between negative 6 and this asymptote, negative 4. Below that, the graph of g is above. Okay, so I'm going to say negative 6 is less or equal to x, but less than negative 4. So these are the solutions that we needed, okay? X is greater or equal to negative 2 and this other one. All right, 6.3. A graph represented by h of x is given as this, drawn on the same set of axes as f and g. For which values of t will h be a tangent? So the graph can be a tangent, meaning that the graph the graph h and f will only intersect at one point. So if it's intersecting at one point, it takes us back to the nature of roots, where the b squared minus 4ac should be equal to the 0. Okay, number one, when the graphs are intersecting, they have to be equal to each other. So h of x must be equal to h of x, or h of x is equal to f of x, okay? So we're saying x plus t. Let's just put it this side. We have this as 6.3. which is x plus t, should be equal to negative 4 over, we said, x plus 4 minus 1. Is that correct? Yes. Then let's try to multiply through by the denominator, which is x plus 4. So this is going to be x plus 4, multiply there. We have x plus 4 here, and then we also have x plus 4 there. So meaning that we're going to have x squared plus xt plus 4x plus 4t. This cancels that. We have a negative 4 minus x minus 4. Then all we need to do is regroup, collect the like terms, and then we identify. So it's going to be x squared. This will be x plus a 4x, and then that is going to be a plus x plus a 40, when this one moves that side, it's going to be a plus 8 is equal to 0. Everything of mine seems to be positive. Ne? Okay, so let's see what something is short here. You say this is xt. I don't know why I'm just writing x. Okay, xt plus 4x plus x. All right, so it's x squared plus this is 5x, and then this is xt, meaning that's going to be x into 5 plus t. And then plus, we're going to have a 40 plus 8. So from this, we know that our a is a 0, our b is going to be a 5 plus t, and then our c is going to be 40 plus 8. Okay, so we're saying that for equal roots, okay, for equal roots, the b squared minus 4ac should be equal to 0. So which means a 5 plus t squared minus 4, your a is a 1. Why did I say a is a 0? Oh, Lord. Okay, a is a 1, and then our c is a 40 plus 8 should give me a 0. So when I open this up, what is 5 squared? That's a 25 plus 10t plus t squared. It's going to be minus 16t minus 32. Gives me a 0. So I have a t squared. This and that is going to be a negative 60. What's 25 minus 32? Is it a 4? No. 25 minus 32. It's a negative 7 is equal to 0. Then I just solve this by factors or quadratic formula. So t with a 7, t with a 1. It's a negative, ne? So either t is going to be a 7, or basically t must be negative 1. So that is how I would have approached that question. Okay. Then question number 7. Question number 7, which is the calculus. They want us to do first principles. We know that first principles will tell us that the limit as h tends to 0, f of x plus h minus f of x divided by h. So if this is our f of x, we know that our f of x plus h is going to be 3 over x plus h. Let's do the substitution and see. So that's going to be limit. No, why not put it this side? Okay, so it's saying the limit as h tends to 0, 3 over x plus h minus 3 over x. Everything is divided by h. Let's do the magic, cross multiply and find the LCD. So limit as h tends to 0, we're going to have 3x minus 3 into x plus h. Everything is divided by x plus h, and then we are multiplying it by xh. So this and that, okay? What I'm doing is this, and then that. That's going to be x into x plus h, and then divide by this h also, which is that. Then open that bracket. So the limit as h tends to 0, we have 3x minus 3x minus 3h. This is all over. I don't need to open this. Okay, let me just leave it the way it is. X plus h into xh. So this cancels that. Okay, and then we shall be just left with the limit as h tends to 0. We factorize, so negative 3h over x plus h, and then xh. So this h cancels that. We're only left with a negative 3 over x plus 0. This is now okay. And then there's x outside, meaning that our final answer should be negative 3 over x squared. Okay, so that is how we would have approached that first part of question 7.1. Then 7.2. they want us to find the dx of this. So split this up as you change the exponents. So this is going to be 3 to the exponent 2 over 3 minus x to the negative 3 over 2. Why am I saying 3? Guys. So I'll separate this x to the half and then x to the half as well. Okay, so let me simplify this first. When I subtract, so 2 over 3 minus that, I'm getting just 1 over 6. Ne? Minus, this is x negative 3 over 2 minus, I'm just getting a negative 2. Then let me find the dx. This is just the simplified format of this whole thing. Then my dx is just going to be 1 over 6x, okay, negative 5 over 6. And then this is going to be a plus 2x to the negative 3. Leave the answer the way it is. 7.2.2 must find dy dx if this is that. Step number 1, take out what is common, which is the y. You'll be left with x minus 1 is equal to x squared minus 1. Then we're going to divide both sides by x minus 1. So I'll say this is 7.2. So y into, we said x minus 1 is equal to, it's going to be x squared minus 1. Let's see again. Yeah, perfect. So divide both sides by x minus 1, x minus 1. So this cancels that, but we know that our x squared is the same as x minus 1 and then x plus 1. You're dividing it by x minus 1. This cancels that, meaning that the original expression is supposed to be like this. Now we need to find the derivative, okay? So our dy dx is going to be just the 1. Derivative of a constant is always 0. Okay, 7.3. The gradient of a tangent to the function that is represented by this at this point is 12. Can we show that a is 2 and b is 3? So I have ax squared. This is 7.3. So ax cubed plus bx squared. That's what they're telling us. It has the gradient, okay, 1 and 5, and then the gradient is 12. So 5 marks to get a and b, or to show that a is that and b is that. So step number 1, let's just substitute this into, okay. So if x is 1, y is going to be 5, meaning that we're going to have a plus b should give us a 5, because 1 cubed is 1, 1 squared is 1, okay? So that's the first equation. We can say a is going to be 5 minus b. Call that equation 1. Then for us to look at the gradient, we need to find the first derivative, okay? So f prime of x is going to be 3ax squared plus 2bx, okay? But then if x is 1, the gradient is 12, meaning that 3a plus 2b should give us what? 12. But a, let's call that equation 2, okay? Let's substitute equation 1 into equation number 2. Okay, so that's going to be 3 into 5 minus b plus 2b should give us a 12. That's 15 minus 3b plus a 2b equals 12. Let's make life easy. Negative b is equal to negative 3, meaning that b is a 3. Is that what they told us? Perfect. Then for us to get a, we substitute into equation 1. So it's a 5 minus 3, which becomes a 2. Hello. Oh, okay. Then calculate the coordinates of the points on the curve where the tangent to the curve is parallel to the x-axis. So if the tangent is parallel to the x-axis, meaning that the gradient is going to be 0. Okay? So what I need to do, or what I did in this case, I first substituted back the a and the b. so that the original equation of f becomes 2x cubed plus 3x squared. Then I can substitute, or I can find the first derivative. I don't know why I didn't substitute the first derivative. Hello, to 6x squared plus 6x. Just equate this to 0, because they told me the gradient coordinates of point where the tangents to the curve will be parallel. So if it's parallel, which means the gradient is 0 at that point. Okay, so equate it to 0. Solve for x. So 6x will be x plus 1. So either x is going to be 0 or x is going to be -1. Now let me substitute these values into the original. So f of 0 is going to be 0. And then f of -1 is going to be 2 times -1 cubed plus 3 into -1 squared, meaning that we have a -2 plus 3, which is a 1. So either we're looking at a point 0 and 0, or we're focusing on -1 and then 1. What is the question asking for? Calculate the coordinates of the points on the curve. All right, so that is how I would have approached this question. Okay, so 22 marks. Né? Question number 8. This question. Shows people flames, this one. So the following information is given relating to a cubic graph f. So f of 0 is 0, which means the graph is cutting the x-axis, so the origin. F of 3 is 0, meaning that x3 is also an intercept. Okay, so we have 0, we have 3. Then f prime, this is a turning point. Then this is also a turning point. Then the second derivative 2 is equal to 0. This is the point of inflection, okay? And then the second derivative is less than 0 or values of x greater than 2, so which means it's concave, okay? In that sort of direction. So explain the meaning of the second derivative is less than 0 for x is that. So it means that we're talking about concavity, no? But concavity downwards, okay, concavity downwards occurs when x is greater than 2. Literally, that is what they're asking for. I mean, this is the first. Is it the first? No, it's not the first. Where we see explain, you must write a statement. All right, then 8.1.2, draw the sketch of the graph f showing all the relevant points. Okay, I'll just squeeze it here, né? Because all we need is just the intercepts and then all of that. So if this is our y, then this is our x. So we said this is a point of interest. We said 1 is going to be a turning point. And then we said 3 is also a turning point and an intercept. Now, with the conditions that they gave us, I believe we're going to have a local minimum at 1, and then we're going to have a maximum at 3. So my sketch would be something like that. Something like that. Okay, so that is what I'm having. Okay, this is what we're having. I don't know. Let me know how your graph was looking like. Okay, so we need the intercepts, we need the turning points, and then, yeah. And then 8.1.3, determine the values of x for which f prime of x. So this is the gradient and the graph itself. So there are two conditions. Either this is a positive or negative, or it's a negative and a positive. So let's answer this question and see. So where do we find the graph or the gradient, the graph to be increasing, but below the x-axis? So it's increasing from here up to here. So 1 up to 3. So I can say 1 is less x is less 3. And then where do we find the graph to be decreasing, but above? So it's decreasing from this point if it's above, meaning that x needs to be less than 0. Okay, so that is what I would have obtained in that format. Then with the same information that we have, it is further given that f passes through this point. Determine the equation of the graph. Leave your answer in this sort of form, where P, Q, R are constant values. Now, there is quite a lot of ways of doing this, but I already have my intercepts. Okay, I have a 3, I have a 0, meaning that life is so simple for me. The only thing I need is that point W, 5 and negative 4, 0. Okay, so 5 and negative 4, 0. So we know that the general format of a cubic function should be ax cubed, and so they give us px cubed, okay, plus qx squared, okay, and then plus we have rx plus a constant automatically, which is what? A 0. So for me, what I'm going to do, I'll just say y is equal to a into x minus x1, x minus x2, and then x minus x3, since I have the intercepts. But now, since one point is an intercept and it's also a turning point, which means I need to square that point. So I'll have y is equal to a x minus 3 squared. Okay, and then I'm going to multiply this by x minus 0, which is just x. I can say minus 0, which is just x, okay? Then at this point, just substitute so that I can get the value of a. So negative 14 is equal to a. What is 5 minus 3, which is a 2 squared? And then this is a 5. So negative 14 is equal to a. This is 4 times 5, which is 20. Divide both sides by that, which means our a is going to be a negative 2. Then let's rewrite it out. So meaning that we have negative 2x into x minus 3 squared. Technically, okay. So if that is true, then we're going to have negative 2x into, that's going to be x squared minus 6x plus 9. Open it up, negative 2x cubed minus, no, it's a plus 12x minus 18x. So P is negative 2, Q is a 12, R is negative 18. Okay, so that is how I would have obtained that, okay? Trying to get the root of the simultaneous, we shall spend a night here. Let's go to question number 9, which is the last one. Hallelujah. So an industrial chemical is stored in rectangular containers with square box x centimeters. The height is given as h, shown below. The volume is this. The 9.1 determine the height in terms of x. So we know that volume is length times breadth multiplied by height. So our volume is 2,160,000 is equal to x squared multiplied by height, because x and x squared. Then we divide by x squared. So it's 2,160,000 divided by x squared. That's what the question wanted. 9.2, for safety reasons, during the transportation of the containers, a triple layer of material is needed at the base. Ignore the thickness of the material. Can we show that the total surface area of the material used for the container is given as this? Now, we know that a chemical container, this chemical simply means that we need to cover it up. The top and the bottom, it needs to be closed, okay? So let's start by determining the total surface area of a rectangular prism, meaning that we have 2LH, 2LB, and then twice BH. So it's going to be twice, our length is x with h, okay, plus twice x and x, which is x squared, and then plus twice the x and h. Now, this is just the normal format. Now, if we talk about 3 layers, okay, we're now discussing 3 layers, meaning that we are increasing something extra. Already we have this as the first layer. So meaning that we need 2 extra layers of x squared. Okay, so I'm going to say plus another 2x squared. So 2 layers and then the third layer, okay? So meaning that we're gonna have 4x squared plus 4xh. So we already have the 4x squared from the question, which is that, né? Perfect. So for h, we're gonna use that. So it's 4x squared plus 4x multiplied by 2160,000 over x squared. All right, so this x can cancel 1x. What is 4 by that? So 4x squared plus 2160 times 4. We're going to get 8,640,000 over x. Isn't that what the question wanted? How beautiful it is to be given answers, né? 9.3, to determine the dimensions of the container that will ensure that we have a minimum amount of material used when making the container. So when you talk about the minimum material, meaning that we need to get the derivative optimization, the a by the x. Okay, so initially it's going to be 4x squared plus 8,640,000 x to the negative 1. Okay, let's find the dA by dx, meaning that this is going to be 8x. This is going to be minus 8,640,000 x to the negative 2. Should be equated to 0. Then I'm just going to rewrite this out and say it is 8x minus 8,640,000 over x squared. Multiply through by x squared, meaning that we have 8x cubed. I'm not cancelling, I'm just multiplying through. Okay, is equal to 8,640,000. So over 8 and then over 8. Okay, so if I divide by 8 on either side, simply means that x cubed is going to be, say, 8,640,000 divided by 8. Getting a weird answer, 1080,000. And then I need to find the cube root on either side. So if I find the cube root, you are lying. Okay, cube root of 10. No, I didn't say I'm lying with the answer. The answer is correct. 1080,123. The answer I'm getting is a root form, which is 102,60. I don't know. Then remember we want dimension. So for us to get h, we just go back to the 2160,000 divided by this squared. Okay, so 2160,000 divided by 102,60, and then you square that. Are we doing the right thing, guys? 2160. Guys, help me out. If I'm going wrong, I apologize in advance. So the height I'm getting is basically 205,15. Okay, so if that is all we need, because that's what the question basically asked for. See, that's what the question asked for. Yeah, technically, it's more or less correct to say it's 2159 and so on. So if you round off, you could get more or less the same as the 216 that they wanted. All right, guys, so that is that. I'm sorry for the mishaps that happened for some questions there, but remember, memorandum is not yet out, but this is just the proposed or the guideline of what could be expected, okay? So for my rating, I'll say out of 100, yeah, I'll give it a 98. Not so bad, okay? It was better than some people's papers, okay? All right, guys, so let's meet when we meet for paper 2. I wish you all the best in your paper 2. Bye-bye for now.